The fundamental theorem of calculus. I'm sure you guys saw this in Calculus 1, but let's do a quick review. This is a theorem. This is actually a very big theorem in mathematics. The fundamental theorem of calculus is a theorem, FTC. All right. If we let f be a continuous function, so let f be continuous, on a closed interval. There are two parts to the fundamental theorem of calculus. The first part is the very important part, but the second part is the one we're going to be using a lot in this course. So I'll write the second part first. Part 2. It says that the integral from a to b of f of x dx is equal to f of b minus f of a, where capital F is the antiderivative of little f. So the integral from a to b of little f of x dx is equal to capital F of b minus capital F of a, where f is antiderivative, capital F is the antiderivative of little f. Now, part A, or part 1 of the fundamental theorem of calculus is actually my favorite part, but it's the least important part in our course. It says that if you define a function a of x as the integral from a to x of f of t dt, so you're defining a function essentially by looking at the area under the curve of f of t, where x goes from a to b. Then we can find the antiderivative of this course. Then a prime of x is equal to d dx from a to x of f of t dt, and this is just f of x. So the derivative of a of x is just equal to f of x. So we're not going to waste too much time on part 1 of the of the fundamental theorem of calculus. If you want to know more about it, just send me an email and we'll talk more about it. So let's do some examples involving the part 2 of the fundamental theorem of calculus. Examples. All right. Number 1. Let's find the antiderivative or the definite integral of 3x squared plus 2x dx. Okay. So the fundamental theorem of calculus says take the antiderivative. Let's look for the antiderivative of 3x squared plus 2x is the same thing as 3x. Then you use the power rule, which means add 1 to the exponent and divide by the result, plus 2x. There's already 1 here. Add 1 to the exponent and divide by the result. Okay? So this and that, this and that. Okay? So what do? You plug in 0 and you plug in 2 and you subtract. So this is the same thing as 3x squared over 3 plus 2x squared over 2, and then you go from 0 to 2 and then you cross this out and you're left with x squared, x cubed, cube over here, x cubed plus x squared plug in 0 and 2. So this becomes 2 cubed plus 2 squared minus 0 cubed plus 0 squared. So this is equal to 8 plus 4. So this is a nice 12. Okay. Now, let's try another example. Example 2. Call that example 1. I'm going to circle it. Just to make everything uniform about that. Alright. We want the antiderivative, actually the definite integral from 1 to 2 of 3 over t dt. So this becomes, we can actually factor out the 3, 1 to 2, 1 over t dt. So this is 3. The antiderivative of 1 over t is natural log. So we just have natural log of t, of the absolute value of t actually, 1 to 2. This becomes 3. You have natural log of 2 minus natural log of 1. But the natural log of 1 is 0. So we're just left with 3 natural log of 2. Very good. Let's do another example. Let's do example 3. The integral from 0 to pi over 4 of 2 cosine of x dx. All right. So we have, you can factor out the 2 if you want to begin with. Or why not? Why do we need to factor it? We don't have to. Let's look for the antiderivative of 2 cosine x is 2 sine x, because the derivative of cosine x, or the derivative of sine x, is cosine x. So you plug in 0 and you plug in pi over 4. So we're left with 2 sine of pi over 4 minus 2 sine of 0. So this is 2 times sine of pi over 4 is root 2 over 2 minus 2 sine of 0 is 0. So this is just square root of 2. All right. I am going to do one, and I'm going to do it really quickly, and then we talk about why I did it really quickly. So this is number 4. About number 4. Why am I skipping a line? Let me just do it there to fit everything in one line. Number 4. This is the integral from negative 1 to 2 of 1 over x squared dx. So this is the integral from negative 1 to 2 of x to the power of negative 2 dx. So if I use the power rule, this becomes add 1 to the exponent, I get negative 1, I divide by negative 1. So this just becomes negative 1 over x. And then I'm going to plug in negative 1 and plug in 2. And this is the same thing. This is equal to I can factor out the negative actually. then plug in 2, and then plug in -1, right? And then I claim, or I see that this is -3/2. But then I also claim another thing. I claim that everything I did here is wrong. And this is wrong. I actually claim it's wrong starting from here. And the answer or the question is why. All right, I want you to think about this and tell me why this is wrong in class. Okay, now, and then I want to try a fifth one, number 5. How about the integral 0 to pi over 4 of secant squared theta plus 1 d theta? Okay, the answer to this is 1 plus pi over 4. So I want you to try this by yourself. Oh, let's just call it, it's technically not homework, but is try this yourself. And maybe you can show me how you did it in class. Okay, so that's all I want to say about the fundamental theorem of calculus.